Welcome, folks, to the first ever Vermont Lakes and Ponds Program webinar series. We are going to start today with the Vermont Inland Lake Scorecard. My name is Angela Shambaugh. I'll be presenting the information today, but I do want to call out the folks that were actually responsible for creating this scorecard, and that's Leslie Matthews, Mark Mitchell, and Kelly Merrill. Amy Peacott had the idea of the scorecard now back in 2010. But it's Leslie, Mark, and Kelly that have really made it come together this time. So what you're seeing is all due to their efforts. So let's get started. First, a couple of webinar housekeeping things. I actually have not set the microphones to mute since it appears there's only one person online. We are recording the presentation, and we'll post a link to that recording on our scorecard homepage, provided that the recording goes and does what it's supposed to do. There is a chat box on the lower left of your screen. We will be monitoring that throughout the presentation, so feel free to note any questions there, especially if you have any technical difficulties. We want to get those fixed before we go any further. So the original Lake Scorecard was developed in 2010. As I mentioned, it was from an idea that Amy Peacott had after looking at other similar ways to communicate information about overall lake health. It was designed to answer two questions. The first is, how is my lake doing? And the second, what can I do to protect my lake? Those of you that have visited the scorecard page know that we use the SECI icon to share that information, focusing on four key water quality issues. And then we also have the checklist, which you see here on the right side of the screen, which provides information on the kinds of actions that you can take to protect your lake water quality and improve it as you go along. So the new scorecard builds off of that original scorecard model. We continue to use the SECI icon. We continue to focus on four key aspects of lake health. For the 2017 scorecard, those are nutrient trend, shoreline and lake habitat, invasive species, and mercury pollution. The 2017 scorecard includes all of our data up through 2015. We've added all the lakes that are in our inventory, so a total of more than 800. The scorecard at this point does not include Lake Champlain. The presentation of Lake Champlain got too complicated, and Google Earth couldn't accommodate some of the ways that we needed to record that information. So for now, the Lake Champlain information is not shared by the scorecard. As I noted, the information covered by the four quadrants of the SECI icon have changed. The other thing that's changed is you'll notice in this particular example of the scorecard there is a lot of gray. In the earlier version of the scorecard, when we did not have information, we listed that quadrant as being in good condition and showed it as a blue color. We've decided that that's not a good way to represent those lakes that don't have information, so for now, and moving forward, when we do not have information about a particular set of data, we'll color that quadrant gray. And then finally, we're also using terminology that fits better with the EPA resource assessment, so good, fair, and poor, as compared to good, fair, and reduced, which is what we had used previously. So let's look at what happens when you go to visit the scorecard. When you zoom in using Google Earth, you'll see the colored SECI icons. There will also be a layer that today is not functioning, of course. There will also be a layer that shows you the outline of the lake watershed as well. When you click on the icon associated with your scorecard or with your lake, you'll get the Inland Lake Scorecard popping up. Again, the SECI icon is there to share information about the four key areas of lake health that we're focused on, but you'll be able also to visit several links. This one here, the detailed nutrient trends and status, is a pop-up that will provide deeper information, and I'll share that with you in just a minute. You can also look at the plant list and the fish list for your lake if that data is available. We again share the color coding for the SECI icon. If you really want to dig deeper into how the lakes are scored, you can click here, and this will take you to a 9-page document where we have laid it out in all sorts of detail for you. I'll be covering aspects of that today during the presentation, but if you really want to dig deeper, that's where you go. And then finally, this last link here, learn how to maintain or improve the lake score, takes you to that checklist that I showed you earlier. We've updated it with all of the new things that we're doing as well. So let's look at that deeper information. So when you click on that link that says nutrient trends and status, this is the pop-up that you will see. The scorecard Secchi icon is here on your upper right. We have a box with characteristics and statistics for your lake, the lake area, the maximum depth, the mean values for several parameters. The middle part of the box captures nutrient data and data that are connected to nutrients. So spring TP, spring total phosphorus, summer TP, summer chlorophyll A, summer Secchi, and all of these are data that are collected by the lay monitoring program. So if you have a lay monitor on the lake that you're looking at, there will be graphs in this spot. If there is no lay monitoring information, this will be blank. You'll notice that each of the graphs is also color-coded, and that corresponds to the trophic status as noted in the lower part of the diagram. Off to the right side, this trend score connects to the nutrient quadrant and these other bits of information. Again, I'll share more about that as we go deeper into the presentation, but these are all specifically referring to pieces of information that we've put together about the lake that you're looking at. So let's start with nutrient trend. Again, that's the upper left quadrant of the Secchi. It's captured by the 4 graphs in the middle of the pop-up page and also by this trend score at the top of the right side. The data shown in the graphs are the annual means for each of these different parameters, and it takes at least 8 data points each year to populate the summer data graphs. So if there were not 8 points for that particular year, you will not see a data point. You'll notice that we've got regression lines as well. We do run a regression analysis on these data. We also run what we call the Kendall-Tau rank correlation of the means. That's a way to look at the trend over time, evaluate the significance of this line and the direction it's taking over time in order for us to determine whether a trend is significant or not. Each of the graphs has a heading associated with it. Tells you the name of the trend that we're looking at. P refers to the probability that that trend is significant, and basically the smaller the number, the more significant that trend is. CV refers to the coefficient of variation, and basically as that number gets larger, it means that the data is noisier. There's a lot more variability from year to year. If the trend is significantly increasing, it didn't work. It didn't work what I planned. So if the trend is significantly increasing or significant at all, you'll see that noted right here, and the color of the text will tell you whether that's a good thing or a bad thing. If it's blue, it means it's a good trend increase. If it's red, it's going to be a trend going in the opposite direction. And you'll see as you look at the chlorophyll trend, the chlorophyll graph further to the right, that the trend here is stable. The points stay white, and the text is black. For this trend that's significantly increasing, both the points and the text turn blue. So based on that information, we actually assign a score to each of these 4 data sets. Oh, now it comes. The 4 data sets then are processed one step further to get an actual what we call a score. In the case of the summer data, we add the score for phosphorus, chlorophyll, and Secchi all together, and then the outcome is ranked on a scale of 0 to 2. That score is added together with spring phosphorus to create what we call the final trend score. For those lakes that don't have lay monitors on them, we will use twice the spring P score to balance that out properly. Lakes with the highest final scores get blue for good. Those with the lower scores, less than 2, are being shown red for poor. So again, when you look at that nutrient quadrant, that is how those scores are calculated. Moving on to the next quadrant, which is the lakeshore and habitat quadrant, we use 2 indices currently. The first is associated with the National Lake Assessment. It's called the Human Disturbance Index. Kelly and Leslie have been using this quite frequently now since it was developed for the National Lake Assessment. So more than 275 lakes in the scorecard are scored for the lakeshore and habitat quadrant using that method. We have 46 lakes that are scored using an older method. As we have time, we will re-evaluate those using the NLA method and change the color of the quadrant to match if necessary. And of course, there are quite a few lakes at this point that do not have data associated with them, so the color of that quadrant for lakeshore and habitat will be gray. If you want to get into the nitty-gritties of the score there, again, for the Human Disturbance Index, a lower score indicates a less disturbed shoreline, so those lakes are colored blue. A higher score, in this case greater than 0.75, the lakes are colored red. And again, if you want to learn more about the exact process that is used to make this evaluation, visit that PDF about how lakes are scored. For aquatic invasive species, which is the lower right quadrant on the Secchi icon, we are doing for the scorecard presence-absence. If you have no known invasive species in your lake, the quadrant is colored blue. If you have at least one invasive species, the color is going to be red. And the list of species that you see here at the bottom of the screen, the two-milfoil species, water chestnut, alewife, spiny water flea, those are the ones that we evaluated for this quadrant. We spent a lot of time trying to find a way to accurately and well present the information that all of you are doing to manage invasive species in your lakes, but we haven't come up with a really good way to do that. So for right now, the quadrant for invasive species is presence and absence. If we can find a good way to share that management work that you do, we'll add that to the scorecard at a later date. The fourth and final quadrant of the icon is devoted to mercury in fish tissue. Back in 2004, the Vermont DEC and the New Hampshire DES conducted a scientific study looking at the accumulation of mercury in the food web of our lakes. Mercury is an atmospheric pollutant that comes to Vermont by way of coal-fired power plants and other industrial sources in the Midwest. It's carried to us in the air and then drops out onto the watershed and eventually makes its way into the lake. So the study that was conducted back in 2004 did some actual testing of zooplankton samples, phytoplankton samples, and fish tissues to find out where mercury was present in a lake food web, if it was present at all. And using that data, they developed a model that we then have used to determine the color of the quadrant for this lake's scorecard. If the model was showing that there is a low probability of mercury accumulation in fish tissue, we've given those lakes blue in the mercury quadrant. If we've actually tested fish tissue and that tissue exceeded mercury guidelines set by the EPA, the color of the quadrant will be red. For all the rest, the color is colored yellow if the model indicates that mercury accumulation in fish tissue is likely. And just to give you an idea, mercury is one of the widest spread stressors for our Vermont lakes. This graph shows lakes that are greater than 10 acres, and you see that we do have 2 lakes where mercury is considered to be a low probability of accumulating in the fish tissue. And interestingly enough, the more phytoplankton you have in your lake, the less likely that mercury is going to work its way up through the food chain. So these 2 lakes represent some of our most eutrophic lakes. We do have 10 lakes that we've tested the fish tissue and know that it does exceed EPA guidelines, but you can see that there's a large number of lakes in this category of those over 10 acres where the model suggests that mercury is accumulating or may accumulate in fish tissue, but we have not confirmed it by doing actual tests of fish. Moving on now to determining water quality status. That is on the right side of the scorecard pop-up. It's captured here by water quality standard status. The color of the text and the name of the text, as well as the color of the lake in the image below that text, tells you how your lake is faring. And this is directly based on the assessments that we do for the EPA every other year to evaluate how well our lakes meet Vermont water quality standards. Each lake has a series of uses associated with it, and we look at each of those uses every 2 years and assess how well the lake is doing. So for the purposes of the coloring here associated with this particular status, we have either impaired or altered lakes, which will show as red. We have lakes that are stressed, which will show as yellow. Those meeting standards are blue. And again, if we have not enough data to make an assessment, you'll see that it is gray. Each lake has more than one use associated with it, so we looked at all of the uses, and for the purpose of determining what color to put in the lake, we used the worst status, if you will. So anytime that a lake is red or yellow for stressed, you can see at the bottom of the page a list of the stresses and impairments, and that can tell you what's going on. So in the case of Shadow here in Glover, the stress and alteration is caused by dam manipulation and flow changes on that lake. So the final thing that we share through this pop-up is watershed disturbance. And all of us know that what happens on the watershed influences the quality of the water in the lake downstream. So we've worked to capture that information because it puts the rest of the data that we've already shared into better perspective. So that is captured. The watershed score is captured here on the text on the right side. And again, we use 3 categories. Highly disturbed lakes will have red text. Moderately disturbed lakes will be yellow. Minimally disturbed will be in blue. And you'll also notice that the outline of the watershed is colored, and that corresponds directly to that watershed disturbance value. The data that we use to generate the disturbance value comes from an index developed by Brown and Vivas in 2005. Basically, there's a GIS layer, and each acre of that land falling within the watershed is evaluated to find out what kind of land use is occurring there. Using this set of classes, we put each of those acres into one of those classes, and then you'll notice here on the right side of the table there's a coefficient of land development intensity. Basically, the larger the number, the more developed the land is. And that's multiplied by the area of the acreage to come up with a final score for the watershed. We've broken that out into highly disturbed. So if the score is greater than 1.7, the watershed is colored red and considered highly disturbed. If it's less than 1.3, it's colored blue and considered minimally disturbed. And you can see an example of a minimally disturbed watershed here. Again, the outline is blue, but we have that underlying Google Earth imagery, so you can actually see that that makes sense, right? This is a strongly wooded watershed, and so it should be minimally disturbed. If you go back to the Glover image, you can see the watershed here is moderately disturbed, and you can see those areas of where the woods have been cleared away. There's a little bit of impervious surface here and also along the edges. So that's another way to go back and learn more about why your watershed may have been scored that way, is to look at that underlying Google image of the land use. So that's it in a nutshell. Again, if you want to explore more deeply on how we did these calculations, please do take a look at that PDF link to how lakes are scored. So now I'm going to actually move right into the lake scorecard and show you how you navigate. Oop, wrong one. First thing you'll want to do is go to our Lakes and Ponds program webpage. If you click under Data and Maps, you'll see a list of everything that we provide. You can click on the lake scorecard. At this point, if you do not have Google Earth installed on your computer, you can click here and download, but then click here to actually open the scorecard. A little pop-up shows up on the bottom of your window. Click on that to open Google Earth. Get rid of those. And then you zoom in to the Vermont Lake Scorecard. Looks a little busy at first. Let's see, looks like I want to take up a couple of other layers here. Yeah, that's better. Yep, so you can play with your image depending on which computer you're on. You may see different things. The one thing that is not refusing to function today, which is refusing to function today, unfortunately, is that watershed outline that I showed you before. Yeah, so the lake, again, the lake is colored depending on its water quality status, and the watershed outline is colored depending on the watershed disturbance status. And both of those layers today have decided not to function, so I can't show it to you. But hopefully we'll have that repaired, and next week when you visit the lake scorecard, you'll be able to see it. But it functions much like the previous scorecard. You can move through the state to look at any lake you would like. You can zoom in closer, go out further, and then when you actually click on the icon associated with the lake of interest, and I'm going to go to Willoughby today, click on that and the scorecard pops up. So these are the active links to get you the plant list, the fish list, to learn how lakes are scored, to learn how the checklist, get to the checklist that you can find all the different things that you can do to improve your score. When you click on nutrient trends and status, it takes a little bit to load, but that pop-up shows up. And again, there's another opportunity to get to how lakes are scored. And you can see in this case, we have for Lake Willoughby significantly increasing trends in phosphorus in both spring total phosphorus sampling and the summer lay monitoring sampling. So the nutrient trend score for Lake Willoughby is poor. Something to pay attention to, all of you working on Lake Willoughby. The one thing that we have discovered, that if you would like to print this out, you actually do need to open up the Lake Scorecard in Internet Explorer. That gives you the option to save an image and print it out if you would like to do so. So there it is again, and then you can work with that with your Internet Explorer to be able to save that information. So again, you've been bumped out of Google Earth. This is open in Internet Explorer. If you want to get back to Google Earth, you need to click on the Google Earth icon and it will take you back. So that is the Lake Scorecard. And go ahead, Mark.
Explain the PDFs, the links to learn how lakes are scored.
All right. That's right. So again, we do have links, and for right now, Google Earth really doesn't like to open up a PDF, we've learned. So if you want to open that, once you've clicked on how lakes are scored, you'll go to open it in Internet Explorer. The file will tell you how to, ask you whether you want to open it, and then you can see that image of how it's scored. So unfortunately, you have to, for right now, leave Google Earth again to be able to open up that link. We're working on repairing that, and it will all hopefully be seamless very soon. You can also, if you don't want to navigate through Google Earth and you do want to find a lake, you can come right down here to this little search box, and if you type the lake in and hit enter, it's supposed to do something. All right. Oh yeah, it brings you to that lake here. If you click on it in the list, then you'll get the scorecard open and you can go forward. It doesn't move Google Earth itself, but it does bring up the scorecard, and you can go deeper like you did before. So in this case, I've chosen Lake Carmi because, again, I wanted to show you some of the differences between the two different types of information that's out there. So like this information, again, will show up, this outline of the scorecard will show up hopefully when you visit Google Earth and open the scorecard, as well as the coloring of the lake. And because Lake Carmi does have some impairments, that stressed impairment list shows up as a drop-down on the lower part of your screen. And I think I've got it all right. Did I miss something, Mark?
Just show the layers on the left-hand pane again. There is 3 layers.
Yeah, there are 3 layers.
So this is the scorecard.
This is the scorecard layer. And there are the water quality standards status. That is the layer that will provide the colored line that outlines the watershed. What's that?
That's the lake polygon.
Oh, I should let Mark explain this.
That's
So but you can see that on right now both of these layers are broken, and we will be working on repairing that so that when you open up the scorecard next time, you should be able to see both these additional layers. And again, if you have any questions, folks in Lakes and Ponds are very willing to help you navigate the lake scorecard, because as you can see, I'm still learning how to do it. So don't hesitate to contact us with questions.